All right, let's build something more advanced. So I'm going to start by turning off all of this. I'm going to hide everything here in Rhino. I'm going to turn this off as well. So we are going to build something a little more parametric. And I have this nice little sketch here to describe what it is that we're going to build. So we're going to try to build several squares. Now in a traditional method, if you were to try to build several squares, I'm not saying this is a super cool thing to make, but you'll see why it's a useful example. If I were to build this in a traditional modeling platform, if I wanted to make 3 of these, I would probably start by building a surface from, say, 4 points. I would select all 4 points, and then I would copy that object multiple times. We're going to do this in a different way in order to make it more parametric, and you'll see the advantages to this new method as we go. So rather than building one full object and then copying that completed object multiple times, instead I'm going to define the object based on a set of rules, because this is really the underpinnings of parametric modeling. So you can think of this square surface that I want to make as based on a base point and the width and height. In this case, our width and height will be the same value. So in order to build this parametrically, I'm going to start with a base point, and then we're going to move that point to 4 different locations, and then we're going to create a single surface from those 4 points. And once we have that code built that says give me any point and any width, it'll generate a square. Then I simply need to feed it in multiple points, and it will generate new squares from each point. So let's go ahead and try to build that. So first I'm going to need a base point. And actually we can copy the code we had before where I had my my point. Let's bring that down here. Okay, and let's turn it on so I know what I'm looking at. Fantastic. So I have 1 point. Now I want to define the edge points. So we're going to do this using a move command. And move is a little different in Grasshopper. Type in move, you'll see it here. So it requires, you can find this out by hovering your mouse over the front. So it requires any geometry. Perfect. I want to move this point. And it wants a motion vector. This is a little odd. So the translation vector is saying from some starting point to where I want to go, where do I want to move this? And if I go to the vector tab and expand this tab, you'll see I have a bunch of different vectors. In my case here, I want to use the unit x because I'm going to define this lower right hand corner point. So it defaults to a factor of 1. So if I plug this vector into the motion tab, you'll see that it moved over by a value of 1. And if I copy this number slider, I can adjust the width. So let's make the width small, 0.25. Zoom in here in Rhino. So you see I now created that point. So I have my base corner point and I have the lower right hand corner. Let's create the one, the upper left hand corner. So I'll copy this down. Instead of using the x vector, I want to use a unit z vector. And because I want it to be a square, I'm going to define it as having the same width and height. So now I'm going to use this unit z vector, override that motion, and you'll see I got that command up there. Now how would we create the upper right hand corner? There are several ways. We could say use the same, I could take this base point and move it in the same direction. So if I were to copy the move command, rather than moving the base point, I could move the lower right hand corner point by the same z vector. You'll see I have that. But I think it's a little bit cleaner if we continue with the base point, but this time use a vector that is this 45-degree angle. And we can create this very easily with an addition command. So using addition, I could simply add the 2 vectors together. And the addition component is smart enough to know the difference that this isn't a number anymore. It also works on vectors, and it gives me a resultant vector that when I plug that in, it gives me this. So I basically added the 2 vectors together to give me that new translation vector. And this is nice and smooth because now I can think of all of these again as being this all derived from the same base point. So now let's build a solid surface between them. So to do that, let's go to the Surface tab, and you'll see under the Freeform Construction tab, 4-point surface is what I want. So let's add the points together. So the base point, I'm just going to throw these in. See, as soon as I have 3, I get a nice little surface popping up. And this happened. It's all twisted. Well, in hovering over these points, I see that my order is this Z-shaped. So what I really want to do is to have it go in a continuous order. So if I have my base point, the second point is there. My third point, I want to be actually this corner. So let's override and swap these two. There you go. Perfect. And now I can turn off my base objects, and we are good to go. I've created one surface.